Tonight is our last talk of the day by Pete Goodliffe. Pete is a director of software at InMusic, which is a brand of Akai, Audio, and a few others.
Newmark,
Air,
yeah.
Newmark. Big group, huge group, so we're really privileged to have him. And Pete has been an advisor to JUCE since the acquisition. And so we had received some very good advice from him over the past few months. It's a privilege to have him here to talk about how to become a better programmer. It's a talk that he's delivered before, I believe, and that was part of the book that he wrote. I've never seen him myself, and as a bad programmer myself, I'm really looking forward to it. So,
cool.
Over to you.
Thank you very much. Thank you. Okay, so, up front, this is a 90-minute talk that once got condensed to 60 minutes, that's now got condensed to 45 minutes, and in that time I've added more because I've added this bit in the middle. So I think I have an average rate of about 3 minutes per slide, and I had no time to tell you that. Hello, I'm Pete. This talk is Becoming a Better Audio Programmer. And technology fails me. This is performance art. I meant to do that. So I'm a programmer, I'm an author, I'm a columnist. I've been writing a column for a magazine for 16 years now, which I believe constitutes some kind of record, but I haven't had that actually proved. And I like to think of myself as a conscientious coder, making the world better, one line of code at a time. And as JB also said, I am Director of Software Development now for Akai Professional, which is cool. And this thing in the background is a product we have literally just released called MPC Touch, and it is utterly gorgeous. I'm very proud of it. It's a beautiful thing. It's entirely built out of JUCE. This is a beautiful 7-inch multi-touch touchscreen. We did a whole load of sort of custom touch interface using JUCE there. It's gorgeous, it's beautiful, and you all need to buy one. Or buy me a beer. Either, but preferably buy one of those. Now, specifically, I just want to make it clear that although I'm talking here and I've written a couple of books, I'll tell you about those in a second, I'm not an expert. Very much I am still learning. So I just want to share some stuff with you in the 45 minutes that I've got, and I should probably start a timer so I have a clue where I am. I just want to share some stuff that I have learnt. Don't presume I know everything, and don't presume I'm right. Maybe we'll talk about that in a bit. I've fairly recently produced my second book called Becoming a Better Programmer. You might get a kind of a theme, because if I told you that my magazine column was also called Becoming a Better Programmer, that's the kind of thing that I really care about. So this talk will be less audio-y, although I have very specifically rammed a whole load of specific sort of audio thoughts in it, and I will try and make it as relevant as I can to you guys. Although I have to say, I love being in a room full of geeks. I love talking in front of geeks, and like being in a room full of audio geeks. Ooh, this is marvelous. So, we're having fun. So the plan of what we're trying to do today, I don't know why I'm holding this because it doesn't work. What we're trying to do today is work out ways to become better audio programmers. And I want to be quite specific about this, because I think if you leave not having any idea how to become better, I have failed, and you can not buy me that beer. So the first question, your starter for 10, do you actually want to become better? Hands up, do you want to become a better programmer? All right, well done, good, good. Second question, does it even matter? Yes. Correct answer. Next question, why? Why does it matter? Because. That's not a bad answer. I've had some terrible ones in the past. Here's one reason. You don't want to be the guy that makes everyone else do this. Yeah? We've all worked with them, yeah? The people, the cowboy coders who just do disastrous work and make a big mess that you end up having to tidy up. It's probably your colleagues. It might be the person sat next to you. It might be you. Just saying. Next question, this is kind of philosophical really, but what actually is better in this context? It's broad, it's hand-wavy. Does it mean knowing more about DSP? Does it mean knowing more about C++ 11 and 17? Is it just how to write optimal code? It could be any of these things, it could be none of those things. But nevertheless, we will try and get better. This is my thesis. It's my observation based on nearly 20 years in the coding industry. I've worked with great people. I've worked with terrible people, to be perfectly honest with you. And the people I've enjoyed working with the most, the people who've been the best coders, the ones who just do really awesome work, have more than just technical knowledge. They have more than a mastery of arcane C++11 lambda function shenanigans. They're the guys with that kind of attitude that is positive, that they care about crafting good code. They don't necessarily write complicated stuff, but they write simple stuff that does the right thing. Attitude is the key to being an excellent programmer. I once had this described to me by someone, the word attitude itself, as being as a picture of 3 axes. Not these kind of axes, axes of a plane. Yeah? So the attitude of that, I did that joke in Kiev. It didn't work very well. I think I was expecting a little bit too much. So the attitude of a plane. I'm going so hand-wavy, but it's going to get worse, so just buckle up. A plane, sort of, its direction is described by the 3 axes. Pitch, yaw, roll. Yeah, I'm not a pilot. I've been told this is true. And that, the 3 dimensions, where it is pointing in those 3 dimensions is called the attitude. And the picture here is, if you have the wrong attitude, even slightly off, and you apply a large amount of power to that plane, you're going to completely miss your mark. So that's kind of just hand-wavy, but it just kind of illustrates how attitude is something that really matters. And of course, Winston Churchill agrees. And it just goes to prove, basically, if you're doing a talk, you can prove anything with quotes. Winston Churchill, attitude is the thing that makes a big difference. Walter Scott, a famous playwright, for success, attitude is equally as important as ability. This must be right. Muhammad Ali, to be a great champion, you must believe you're the best. If you're not, pretend you are. Is that a good attitude? I don't know, that sounds like the excuse of a lot of cowboy coders that I've known. So, you know, you can't prove everything with quotes, but pretend I just did. So, Goodliffe's taxonomy of programming shenanigans. We learn things, we learn specific things, and you're here at a JUCE conference, so you're learning some very specific things about JUCE. Maybe you've just learned some of the new stuff about JUCE 4. Maybe you've just, Jules has just thrown some C++11 at you, and you've gone, ooh, I might like to know about that. So there's specific technologies that we learn about. On top of those, then there's the idioms of how we use them. Like C++ lambdas are awesome. I love them. But it's really important you know the idiomatic usage of them. Like that little ampersand makes a massive difference. And if you don't really know what you're doing, you can shoot yourself in the foot. So there are idioms for using those particular technologies. And JUCE, for example, is a library that embodies a massive sort of set of idioms. There are just ways that you use the library. So once you know the technology, you learn the idioms of how to apply them. Loads of my newbie coders who just sort of start to learn JUCE, really, there's that slightly dangerous level that I guess maybe we've all been through, where you understand the things, but you don't quite know the right way to stick them together. And so you make a bit of a monstrosity, an elephantine application. And in doing that, you then learn the right ways of using JUCE, and hopefully you rip it apart and make it again. What you really do is you ship it. Then, of course, once we know the idioms, we learn how to sort of apply these things to the right problems. And I say at the top, I maintain attitude overarches all of these things. If you're doing the wrong thing, there's no point in doing any of it. If you try to if you want to apply some C++11 just for the hell of it, you've done the wrong thing. If it solves a problem and it's the right solution, that's great. So attitude is really important. Of course, we all want to be DSP programmers, by which I mean people who develop software purposefully. So I added that just for you. But I mean this, that the idea of not just banging out code. We know people who just bang out code, who don't think about it, who just, the first thing that comes into their mind, they squirt it out. Developing software purposefully, thinking about the lines of code we write, thinking about the design before we even start typing. That's one thing. And also, I will add to that, developing yourself. I cheated. Purposefully as well. Learning, so this is, I'm talking about us becoming better programmers. So in order to do that, you have to develop yourself purposefully. And you won't get better if you don't think about it. You may learn a few things along the way, but you have to consciously make a decision, you put your hands up, in order to improve yourself. So, how do we get better? Do programmers, like a fine wine, mature with age? Or maybe like a cheese, we just get crumblier and stinkier and get blue veins? Possibly. How do we get better? Well, clearly we have to learn technology, we have to learn idiom, we have to learn how to apply it all. That's a given. Most importantly, we have to adjust, perhaps, or just be aware of our attitudes and the reasons why we're doing some of the things we're doing. I'm quoting myself, who cares? The attitude, most importantly, I don't have time to quote myself. I could have said that now. But most importantly, you have to want to improve. Yeah, you have to want to improve. So, in the 32 minutes I have left, we will do this, and it's going to be fast. We're going to look at some models of knowledge acquisition. This is a very important set of tools that you can use to frame your knowledge and help you to work out how to get better. So pay attention to that bit. I'll go over that like it didn't exist, and then I'll try and spend some time on some specific audio topics, some things that just I threw down a few days ago in a text editor to think, these are things that that I have observed where we may focus effort on as we are audio programmers, and I forgot all about them. So when I describe them to you, it'll be about as much of a surprise to me as it is to you. So this should be fun. And then I'll wrap up and you'll applaud and throw underwear at me and things. It'll be great. So, models of knowledge acquisition. This is my first model of knowledge acquisition. This is some sort of axis of utter liability coder to some super awesome ninja guru dual status genius. You, my friends, are somewhere on this axis. You may be here, but no, let's say we've adjusted the scale and we've normalized, you're here. This is you now. You want to be here sometime in the future. This is, of course, utter bunk. As an aside, where do you want to be in the future? This is just amusing. So, famous quote that was misattributed to Niels Bohr, prediction is very difficult, especially about the future. In 1962, the Decca Recording Company turned down the Beatles. They said, we don't like their sound, and guitar music is on the way out. It just proves it's really hard to predict future trends and what you should invest in. They failed to invest in something, they missed out. 1974, our lovely Prime Minister, well, when she was a Prime Minister, Margaret Thatcher, she said, and this is a classic, it'll be years, not before my time, before a woman will become Prime Minister. Now, this just goes to prove that you can be spectacularly wrong and very successful. So, that's the thing. And does anyone know who Ken Olsen is? Or was? No, you suck. Yes, go on. Yes, he was the CEO or the whatever it was at the time of DEC. And it was a famous quote. He said, there's no reason anyone would want a computer in their home. Which just, again, goes to show you can't predict technology trends. So this kind of whole idea of you in the future, goodness only knows where you need to be. But let's pretend you have a clue. Cool, OK. The reason that model was bunk was because there isn't just one axis of you now to you better. There are many different skills. There is the JUCE library. There is the Qt library. There are other frameworks, WDL. There are languages. There's C++, but there's Rust, and there's D, and there's C, and there's assembler, and there's all sorts of JavaScript kind of fun and shenanigans in the Wild West over here. There's so many different skills. And in each of those skills, you are at a different position. Just be aware of that, OK? You might be good at something, but I tell you, you suck at a lot of other things. That's fine. And it's fine. It's fine. So, first model that actually is for real. The 4 levels of competence. I'm a glass half empty guy, so I think incompetence. Abraham Maslow, I'm going to run through these as fast as I can. This is the guy that also postulated the hierarchy of needs, which was like Goodliffe's taxonomy of programming shenanigans, but not as scientific. So this was sort of a 1940s model. And I don't know how many of you guys have seen this, but it's just interesting to understand what he identified was 4 levels of learning, of understanding. Unconscious incompetence, conscious incompetence, conscious competence, unconscious competence. Try saying that when you've had a beer. Unconscious incompetence, you do not know that you do not know something. That's a dangerous place to be. You've just got no idea that you're inept. And the thing is, you are probably unconsciously incompetent about a load of things. You just actually don't know about the things you don't know about. What was it? It was the famous wartime poet, Donald Rumsfeld, that we have the known unknowns and the unknown unknowns and the known unknowns we don't know, we know, whatever. So you move from there, unconscious incompetence. This is cool. I'm a newbie, I join a team, they're using JUCE. I've got no idea about JUCE. My word, it's enormous, where do I start? But that's good. You know that you don't know about JUCE, you've learned that there's a thing called JUCE, and you've learned that you need to learn. That's a good place to be, because now you know you need to learn. Much better than unconscious incompetence. Conscious competence, after a while you've learned JUCE, you have a pretty good idea how to use it. You have to think, you have to go to the docs, but you can now use it. The sort of interesting one is unconscious competence, in the sense that you get so good at something, you don't think about it. Now, if you think driving is a model I often use sort of as an analogy for this. And you sort of go through not knowing that you can't drive through taking your driving test and blah, blah, blah. And these days, how often do I really think when I'm driving? Seriously. I get in the car, shut the door, switch the key on, and off I go, and I end up back at the office. And I haven't really paid that much attention, or I don't think I've paid that much attention. I've sort of done it on autopilot. All my responses are automatically tuned to do that. But was I I jolly well hope I was paying attention, but was I? You know, what if a child had stepped up behind a car? Was I paying enough attention? So unconscious competence could be dangerous. Just hold that in your hand. It's really hot in here as well. If I fall asleep, I apologise. The Dunning-Kruger effect, this is something I'm an expert on. One person got the joke. This is a well-known cognitive bias. Basically, what it says is unskilled people, it follows the 4 levels of incompetence. Unskilled people don't realise that they're below average, whereas skilled people think that they're better than they are. No, other way around. Unskilled people think they're better than they are. Unskilled people, what I said there? It's hot. And they said it with some words. Confucius said it better. Real knowledge is to know the extent of one's ignorance. It's just a well-known fact. And those people who are sort of unconsciously incompetent are dangerous, potentially. So, you know, again, ask yourself the question, in some of the skill areas you're working in, is that you, or is that your co-workers? How does that affect how you yourself should work and how you should work with them? The next model is the biggie, the Dreyfus model of skills acquisition, postulated by 2 brothers, Hubert and Stuart. They did the research in the 1970s, I think, and then this was published sort of around the 1980s. What this was, this is really cool. It works for us as programmers on many levels, so pin your ears back. They studied highly skilled practitioners of fields such as chess grandmasters, virtuoso violinists, airline pilots, guys who really had to know their onions, yeah? And they basically identified 5 levels of learning, and at each of those 5 levels, you learnt in a different way, and you viewed the world, or at least the problem domain you are working in a different way. And that's why it's interesting. So they sort of had these 5 levels that went from monkey to concert pianist, and these levels were called novice, advanced beginner, competent, proficient, and expert. Don't have time, clearly, to really unpack it. However, it's really interesting. So it's a bit more fleshed out than the 4 levels of incompetence, in the sense that a novice, so I'm coming to learn JUCE. I'm a novice. So I now know I need to learn JUCE. I have no idea how it works, but I need to get something done. So what do I need? I can't intuitively do it. So I need a set of rules. I literally need a how-to, and you follow the tutorial, and you tweak the little bits for the application you want to write, you know, hello world with your button and all that kind of stuff. You follow the things that say use the introducer, and when you followed those rules, hopefully what you want to come out at the end. You've got no way of judging whether those rules are any good, you just follow them. But you get a result, and like, you know, Pavlova response, now you're happy. Bell rings, you salivate, it's great. After a while, you move on from, you begin to build a mental model. You move on to being an advanced beginner. Now this is where you can begin to break away from the rules. So you'll follow a recipe for how to get your thing done, and you go, but this needs to be pink, not green, and it needs to be a square wave, not a sine wave, and you change things, and it falls over. But then you sort of begin to learn, you make little deviations, and you learn from doing that. So you may quickly get stuck, but you sort of come back to the rules and you work along again. The thing with being an advanced beginner is you've begun to do enough stuff that you know where to get help. Like you know the Doxygen sort of places that are most useful to you. You know, you've bookmarked component, for example. However, you can't, you know, if you do a web search for stuff, you get a deluge of information. You can't filter which are the good things and which are the bad things, but you're beginning to learn how to learn. Does that make sense? Say yes. Yes, good, right, competent. Now, this is where most people stick. Competent, like you say, he's quite competent. Competent is a great place to be. When you're competent, you've built up that mental model of the subject domain. So I now see how JUCE components sort of fit together, and I understand the hierarchy, and I understand the idiomatic way we use them and how we deal with the lifetimes of these things, for example. I can plan a route into a new problem. I have to make a whole new UI, and I begin to just see, okay, this is the kind of hierarchy, how I would do it, and this is how I'd split up my threads, all that kind of stuff. And I can begin to solve unknown problems. You're not necessarily virtuoso, but you're competent. That's a great place to be. And in many skill areas, this is where we stick. And that's fine. We go beyond that to proficient guys who can sort of, that extra level of learning, you can correct previous mistakes you made a while back. So maybe when you were an advanced beginner, you wrote some tripe, and now you can come back and adjust it and see, oh, I meant to do that, but now I have this greater level of understanding. You can learn from other people, and this is where you begin to get that tacit knowledge, that sort of inbuilt knowledge. Now I just know this stuff. I don't need to look it up. It's a body of knowledge. And when someone leaves a company or leaves a project, and there's an amount of information that they could never write down that's sort of lost when they leave. That's the tacit knowledge. So proficient guys are beginning to build up tacit knowledge, and experts are the proper authorities. Specifically, an expert tends to have a view, a bird's eye view of this subject domain, but also understands how it fits across other related subject domains as well. The specific thing about experts is very much they work from that unconscious competence where they have just an intuition about how to solve something. They maybe don't even understand how much they know. They're just that good. This can be used for good and it can be used for ill. So, for example, this taxonomy can be used to help your learning because you can think about, in some skill area, maybe it's JUCE, maybe it's another language, maybe it's a new problem domain that you're writing a plugin for, say. You can gauge where you are in this and specifically think, this is the kind of way I need to learn. I need rules here. That is fine. Give me a how-to, I'll step through it. I'm aware that I'm stepping through it, and I'm aware that I can't tell if it's good or bad, but I'll just step through this right now. And then when I've done that, I'll reassess where I am. Have I learned some stuff? And that's a fine way to be. The other interesting thing you can do with this model is use it as an aid for your teamwork. If you know you've got someone who's very proficient and someone who's competent, you can sort of get them to pair together. And they've got a similar level of experience and that work really well. If you want to use this for evil, pair a novice with an expert and just watch the feathers fly. It's hilarious. You'd like to think the knowledge would transfer, but the expert is kind of intuitive and doesn't understand and gets frustrated why the novice doesn't understand the stuff. And the novice is going, tell me something, I don't understand all this. And it's hilarious. So, use the Dreyfus model for evil. Again, remember that this model applies per skill. Okay. Another model is, who's read The Pragmatic Programmer? Awesome book. More of you should read The Pragmatic Programmer. It's old, but it's great. It's really good. And they have this picture. I gave this talk in a bank, and I described this picture, and I felt very embarrassed, because I know nothing about finance. But I can tell you guys, and as long as none of you are bankers, and that's not a euphemism, it's good. The knowledge portfolio, they describe, they tell you to think about your set of knowledge as an investment portfolio. Very specifically, you should be spreading your risk in this portfolio. You should have some things that are sort of sure bets, things that you will always be able to get a job in. They're probably not high risk, they won't be high return, but these are your safe bets. And you should also, in that same portfolio, have a selection of things that are higher risk. Maybe it's Rust or something like that. Maybe it's D, and maybe that investment won't pay off. Maybe you won't get a job there, but just maybe you will. And then you'll cream it where somebody else won't. And you should manage your portfolio and understand that there's only so many things you can have in your knowledge portfolio. So maybe you should drop some things and change your investment. Maybe you should drop JUCE and put something else in. Heaven forfend. But just thinking about your working set of knowledge, what you focus on, what you practice on. We'll get to practice in a minute. Purposefully. Develop yourself purposefully. Who knows what that number is? Go, yeah? Hours. Yes, well done. Somebody once said 10,000. It's like, yes, that's the right answer. 10,000 hours. It's this mythical number popularized by Malcolm Gladwell in his book Outliers, but it came from research by Kay Anders Ericsson years ago now. Allegedly, the number of hours it takes to become an expert. Now, it's highly debatable whether it's really 10,000 hours, and Kay Anders Ericsson himself said, well, it's a number, it's a big number, it's sort of somewhere around here. But theoretically, 10,000 hours of deliberate practice is what's required to become an expert in any field. If you want to become an expert in JUCE, you have to invest 10,000 hours of deliberate practice. There's probably only Jules that's done that. 8,000, so this was done on studies of virtuoso violinists, things like that. So the real virtuosos, they did 10,000 hours of deliberate practice. The people who put 8,000 hours in were kind of like the violinists that showed potential. I wish I was one of those. Well, actually, I don't. I hate the violin. But, you know, that's for those guys. And the people who'd done about 4,000 hours were described as music teachers, which is like, don't tell my music teacher. So basically, shove that in your C++ in 24-hour pipe and smoke it. You know, it would take forever to do that. So, there. 5 stages of learning. Who's heard of the 5 stages of grief? Yeah, can you name them? Yeah, okay. Denial, anger, bargaining, depression, acceptance. This is something I observed. And I observed just over the project I'm currently working on. It happens time and time again. Learning is a lot like grieving in the sense that they're both better when they're over. But we go through these phases as we're learning something. So I need to learn a new thing. First of all, denial. I don't really need to learn that. It's fine. I can get away. It's not really an important bug report. It's fine. We'll be fine. We'll be fine. Then, oh, no, I do have to learn it. That's really annoying. After, well, okay, I'll just learn enough to get by. I don't need to know all of it, but hopefully just this little bit. Depression. Oh, blimmin' Henrietta. I never learn all this stuff. It's disastrous. After a while, wait. Oh, okay, it's easy, really. Okay. Phew, fixed it. And we go through that cycle frequently. I mean, some of you guys are smiling, and you know it. So we had to do some freaky Windows operating system interoperability thing, and it was like, oh my word, MSDN documentation everywhere. How on earth are we going to get a head around this problem? And you just go through the cycle. It took about 3 days, and then we were back through there, and it was like, oh, that was really easy. And now we have another problem. So we are doing this all the time. So those 4 pillars are the 3 things we'll base the rest of the talk on, whatever. So those are models of knowledge acquisition. So we want to become better programmers. What I've just shown you is basically some ways of thinking about what you know and how you might learn about some of those areas. So what should you learn? Well, may I suggest there's a wonderful book that could tell you what you could learn. Product placement. It's probably acceptable. I hope it is, because if it isn't, I'm chucked out now. So I wrote a book. That's fine. Actually, I'm not going to cover anything in the book, particularly now. But I split it up there into, you could learn. There are some specific code writing things you may want to learn about. And lots of programs kind of stop just there. I just want to learn some codey thing. But actually, you should focus also in your knowledge portfolio, learning things to do with the practice of programming, how to work with other people, or just how to processes and development tools and all that kind of stuff. Also, personal skills. Coders, we suck at being, generally, I mean, I'm good at talking to anyone with a beer in my hand, but in general, we're kind of introverts. We're not very communicative. We don't know how to talk very well. So some areas of personal skills you really should actually invest hours of deliberate practice in. And yeah, working with others, teamwork. That's all the same kind of stuff. So, I have some topics in my book about, writing code, good design, working with unfamiliar code, how to handle errors well, removing code, go Jules, avoiding unnecessary complexity, all that kind of stuff. You want to focus your effort on some of these things. Maybe some of those things speak to you, and you should just spend some time thinking about how you might improve in that area. The practice of programming, knowing what software development is, good use of version control. Yeah, stuff. Those personal skills. Acting ethically is a really interesting one, because that was the reason I got the book deal with O'Reilly for this book, because I had this chapter on acting ethically. And very few books have any information sort of on that. It's not really something we think about. But using, actually honouring software licenses, for example, is part of this acting ethically. Learning how to learn, that's your personal skills. Working with others, working well in a team, managing your communication skills, being accountable to other people for the quality of your code, building that into your development regimen, those kind of things. So, there's a whole load of areas we could focus on. In the remaining few minutes, sort of with that shenanigans as a backdrop, I have these potentially surprising, because I can't remember what they were, sort of areas that I just want to sort of unpack in performance art in front of you. Let's see where we go with it. And basically, I have a list that I normally do or go through in a talk, and this is a different list because I've tried to sort of make it audio-y. So these are things that I was brainstorming that I see as common sort of code-related areas of improvement that I have seen in some software teams. I said that quite diplomatically, I think. The first thing to focus on, because it's my theme, is attitude, though. I will underpin that again with all of these kind of things I want to look at. Why are you writing code? Do you care about writing good code? Do you care about doing it well with the team? Do you respect the other people in your team? That kind of underpins an awful lot of sort of what you're doing. Do you care about having the most beautiful regular code because you're a code Nazi and it's just like, it must be done my way? Or do you care about it because actually I want this to be a high quality code base, I want everybody to be able to work on it really well? There's two reasons for doing that one thing. One is the right reason and the other isn't. And just be mindful of that. So we'll stop banging this drum at the end of the talk. Solve the right problems. This is something I see people often writing audio apps, and they seem to spend all their time obsessing about the thing that they didn't need to obsess about. Or this may be a theme that we get to potentially in a little while, optimizing the wrong things. Or, I need to have a really elegant component, sort of audio graph, so I'll make my own when there's one built into, for example, the JUCE library, or just doing things that weren't necessary, making something overly general, when actually, if you just made a specific version of something now, you may never have needed the general version, and so you could have saved your time. So that kind of maturity in a developer of knowing when to do something, when not to do something, and sometimes when to just do the half-arsed version because that's all that you need right now. And when you need the other buttock, then you can do the whole-arsed version, for example. So, yeah, that's it's a skill, and it's something you learn as you go along. And I think I have personally more of an intuition about what I should and shouldn't do these days. But even if you haven't got that experience, you should just, whenever you're making a decision, think, is this right? Am I doing the right thing? So yeah, go for half-assed. That's the thing you should take home from today's talk. Right, okay. Next one, taming complexity. This kind of goes hand in hand. I have seen so much tortuous, disastrous code in my life. I mean, it's not just audio code, but we've seen this kind of stuff, and some of this is just in the guise of just ineptness, really. Sometimes this kind of stuff is called optimization. You write an algorithm, and you think, oh, this has got to operate really, really fast. So you just write balls, utter tripe, and then there's a click somewhere, and you're like, okay, right, so. Oh, right, well, how am I going to find it now? This algorithm is disastrous. So learning how to actually write the right level of complexity, because here's the thing, yeah? Software is complex by nature. If it wasn't complex, people wouldn't be paying us mega bucks to write it. So there is a level of necessary complexity in what we do. That is fine. The thing that we need to weed out is the unnecessary complexity. Now, that manifests at multiple levels in our code, yeah? It's what I'm saying, it's the lines of code, it's the design of what you do, and it even manifests at the architectural level. And again, this is take a step back and look at what you're doing. Do you need this multi-inheritance, complicated architectural design for this really very simple plugin, or do you just want the class? I literally have seen that in the past, where somebody's engineered this really complicated general thing, and it was an audio processor, yeah? Just one class. So the idea that we should be looking at is to strive for simplicity, remembering that simple code is not simplistic code. Obviously you have to write the code that does what you require. It's a high quality DSP implementation of the thing you need to do. It's got the appropriate UI, but so it doesn't miss features because that would be simplistic, but it doesn't need to be ludicrously complicated. Again, that's it. Veterans, experienced coders will just enter a project, and you know when you look at something and you go, yeah, this is good. I understand it. It's simple. Versus you walk into, but it's not simplistic. It's just this is beautiful. And JUCE has that kind of thing. When you open up some of the source files, you just look at everything's regular, everything makes sense. That's simple, but it's not simplistic. It's just not needlessly complex. And that's the kind of thing we should be striving for. So I just exhort you to think along those lines. Writing less code. Now, Jules' talk earlier I thought was awesome. And this speaks specifically to this. I mean, as a piece of performance art, it was great. But another good friend of mine, John Jagger, has a blog called Less Code, More Software. Some of my favourite coding moments have been removing code. You know, I have made code better, literally, by removing it. There's some file I/O code in one of the projects I was working on, and it was this deeply nested, inheritance hierarchy of families of file loaders, and is it MIDI style, is it audio style, is it one of these subclasses, with template method style, preload, postload, malarkey. You couldn't understand. It was thousands and thousands of lines. And we took it down to 4 functions, which were about 20 lines each. It's like, there was just no need for that code. And all it did was stand in the way of you seeing what was actually going on. So, I mean, that was one of my favorite programming days, or a couple of days anyway, where we actually wrestled quality back into the code base by removing stupidity. But even so, improving it by removing it, just writing as little code as possible, is not, again, an exercise in being simplistic. It's just darn good practice, and we should all be doing it. Allied to complexity, again, is optimizing the right thing. And it, more often than not, isn't what you think it is. Rule number 1, and we know this, but well, at least I know this. But you know, how many guys have you worked with who have gone, okay, we have a performance problem. Here it is, I'll fix it. No, did you measure? Did you measure? Always measure, and then optimize, profile, and then find the place that's slow, and then focus your efforts there. Very often, when we try to write something that's optimal, it isn't the thing you think it is. If the audio performance is laggy, maybe it's because your UI sucks. Measure, find out where the CPU is spending all your time. So, you know, premature optimization is the root of all evil. We know that. However, that doesn't, so I'm exhorting us not to just write gratuitously complex and convoluted algorithms in the name of optimization up front. Doesn't necessarily mean you need to write a stupid, brain-dead algorithm that's clearly going to be too slow. And more importantly than that, it doesn't mean that you don't design up front, because with a little bit of thought before starting an architecture or a design, you can design something that inherently is performant, that works well. But you have to think about it beforehand. So you don't have a simplistic design. You just have a design that leans towards performance by its very nature, and then you don't need to spend time optimizing the wrong thing because you designed it carefully up front. Again, that's the kind of thing that I think we as developers gain intuition and understanding of over time, but it's something to be mindful of, and maybe you should sort of consider where you are on the old Dreyfus scale in regard to this. Next one, build the novel and delight the user. I'm just fed up of people keeping writing reverb algorithms or you know, another blimmin' plugin that does the same thing. We've got enough of those, and a lot of the kind of stuff has almost become library material, and we don't need to rewrite that stuff. Unless you are performing deliberate practice and you actually want the experience of doing it yourself. We have, I don't know, in our IP, in the company, in our stock pool of stuff, we must have about 5 compressors or something. I wrote another compressor. Why did I write another compressor? I've never written a compressor, so I thought it'd be cool. But I did it for fun, and then I haven't used it in real life. But so that was a code kata. I did that to learn, but in general, think about the products you're making, basically. Solve the right problems, and spend your time on the things that delight the user, that add value, and don't just keep rewriting the same bloody thing again. Does this make sense? You know, there's a few people nodding and looking happy, but yeah, these are all things that I've observed. I particularly care about this, using sharp tools. You know, there's loads of tools to our fingertips, so JUCE is one of them. But the languages we use, the tool sets, even the bug tracking systems, the things that we can draw on to help us work better. Select sharp tools. Look at the things that you touch day to day. If you're using, you know, a proprietary access database for your bug management, stop it right now. Go and get a grown-up tool. They're free and they're hanging off trees for you to pick. pick some sharp tools and learn to use them well, because it could very much supercharge your software development more than learning another language. Learn JUCE well. Maybe you should invest some time in learning C++11. If your compiler allows you to do it, you don't have to go mad, but some of those little features that they give you for free could really just speed up your development, make your code safer and faster and better. So seriously consider learning those things. Somebody else's tool, I kind of tend to also see in some of the teams I've worked in, the desire to build more tools themselves. We want to do something, so we'll build a tool to do that. And it's like, well, you could build a tool to do that, but it'll take you time, and it probably won't work very well. When again, you could pay some money for someone to do the tool, but it would be cheaper overall to do that. So again, that's another exhortation. Pick the right tool, and it might not be the tool that you make. So now here's a big one. With threading comes great responsibility. There was a time on one project I physically banned people from writing the word thread, with a threat that I would cut off your hands, at least a finger, if you typed it. I guess probably that's enough, really. Just if you're going to start a project, if you're going to start any kind of, it doesn't have to be an audio project, but think about your thread model, work out the architecture for threading sensibly beforehand, and it probably doesn't, maybe in our audio world when we have our audio thread and our message loop, there are some clear threads, but if you use the word thread, you have probably done it wrong. Here endeth the lesson. So also something that I'm really passionate about is how to build in the quality in your code. Look at how you develop right now. How do you make sure that the code that you are writing right now is the best code it can possibly be? Not only from the product point of view, how do you make sure you're writing the best plugin you could possibly write right now, but how do you make sure that the lines of code that you're writing right now are the best lines of code you could be writing? Are you unit testing? And you're running the unit tests. I mean, there was a team that was writing unit tests left, right, and centre, but they never actually ran it. And then I went, okay, so I ran their unit test for them, and it failed. And it's like, well, yeah, we never run it because it doesn't work. Okay. I also had a case where I'd written a whole load of unit tests. This is on my project right now for our event list, the sequence of plays. And somebody made an adjustment. And then he Skyped me and said, well, I had to remove your unit tests because they didn't work. Like, yeah, well, they worked before you touched them. And yeah, he completely cocked it up, as you might expect. But how are you, not just unit tests, are you pair programming? Are you do you have a review system in your code? Do you have, literally, you have to have merge requests, nothing's on the main line until it's good. Are you doing anything that ensures quality in your code? Now, coding guidelines and standards, they can be a source of arguments, needless debate. On the other hand, do you have some kind of conventions that everyone sort of subscribes to? Is there a quality bar for your team, for example? I'm not telling you what you should do. I'm just asking you to honestly look at what you're doing right now. How do you know it's the best code you could be writing? If you can't tell me that I know that this is the best code I could be writing, how do you change that? Go away and change it. Yeah? So, I think I've got 5 minutes left. We're sailing down to land now. The art of communication. This is something that any kind of programmer really just should spend some time thinking about. As I said, we suck at communication. This is something that I think possibly one of the soft skills that programmers should actually deliberately practice. Spend time talking to people and learning how to communicate. We know that code is communication, and the code we write communicates not just to the compiler in our language, because we have a compiled language, but also to the other people working on the team on that same code base with you. But it also, we talk, we write emails, we instant message, we pick up the phone, we do video conferencing. All these kind of things are different forms of communication, and it's a skill that we tend to, broad picture, suck at totally, and so we should practice at it. A classic one is video conferencing. A whole load of developers, it's not self-aware enough to realize they're sitting back like that and ignoring someone. They can see you, they're on a camera. It's not like listening on the phone, so learn some etiquette, learn how to show someone respect by actually paying attention to them. So there's a whole kind of world of communication that we need to learn and develop ourselves in. if there's anything to spend time deliberately practicing on, then, as I say, buy me a beer and we'll do some practice this evening later on. So that's a list of things. I went through them at rocket pace. Maybe some of those things apply to you and actually sort of resonated with you right now. Maybe they didn't, in which case you're a genius and you can go away feeling happy with yourself. But again, remembering those models of knowledge acquisition and all those things you're doing right now, think about where you lie. What do you know? What are you slightly dangerous about? What should you actually just do rule learning with? What should you, what can you help others learn about? Think about that Dreyfus model. So Einstein, more quotable stuff. Any fool can know. The point is to understand. So you all said, you put your hands up. You literally practically all put your hands up and said you want to become better programmers. Maybe this has been helpful, maybe it hasn't. Hopefully it's been entertaining. But, so Dr. Zeus, there's no reason for this apart from Dr. Zeus is cool. The more that you read, the more that you'll know. The more that you'll learn, the more places you go. The more that you learn, the more places you'll go. Remembering, I think, becoming better is all about attitude. Maybe none of the things I mentioned in my little list there resonated with you, but there's something else that you can improve in. Is that your attitude? Do you care? Do you want to improve yourself? Where are you going to focus some effort? So yeah, from caring comes courage. More quotes. What will you do now to improve? In the sense, I just want to throw that out to you. Right now, think about all the things that we've been talking about, the kind of the areas, the vague areas that we were sort of identifying. What is the one thing, more than anything else, right now that you are not so good at, that you really should spend some time on because it's the most pertinent thing for you right now? Just think about that. What's that specific thing? As you go away, maybe this evening, maybe over the weekend, think about, put a plan in place. How are you actually going to get better at that? Are you going to actually spend some time thinking about how you communicate? Are you going to spend some time building in quality to your code base? I want you to think of the one thing that you really could invest some time in and put some blimmin' effort into doing it. You'll be doing yourself a favour. And if you can't think of anything, then I suggest you go and buy this book because it's got a whole load of suggestions of things that you can do. And with that, that's just been a whole lot of hand-waving. I hope you've enjoyed it. I hope you've had a great day today. And I hope that you have a good evening this evening, and tomorrow will be excellent. Thank you for listening to me. And hooray!